In section 7.5, we'll explore rational expressions and rational equations. Next year when you take pre-calculus, you'll spend quite a bit of time graphing them, but in this class we simply perform operations and solve the equations. So we're going to start out by asking the question, what is a rational function? And a rational function is a function that is of the form p of x over q of x. So a rational function, r of x, will be of this form, where, and this is important, p of x and q of x are polynomials. And it's important to notice that q of x can't equal 0 because we know we don't divide by 0, right? Some examples of rational functions you've probably seen before. So r of x equals 7x minus 3 over x plus 4. We might have b of x equals 2 over x minus 1. And then we might have c of x is equal to x squared plus 5x plus 6 all over x squared minus 9. Okay, so these are all examples of rational functions, and today we're going to perform operations on them, and then, as I said, we're going to solve rational equations. So let's start out with the first operation, which is to simplify. Okay, so on the screen you'll see I have x squared plus 9x plus 20 over 2x plus 8, and your job is to simplify it. So I just want to put in a warning about bad math that you are going to be tempted to do. And so I want to make sure that you remember we don't do bad math in this class, right? We only do good math. So the way we simplify this is we factor and cancel. Okay, so let me write that over there so you can remember that on each of these, if you're not factoring, you're doing something wrong. Factor and then cancel. So the top factors, very easy, to x plus 4, x plus 5. And the bottom factors, greatest common factor, to 2 parentheses x plus 4. And then anything that matches a factor we can cancel, right? So the x plus 4's cancel, and so our final answer, x plus 5 over 2, boom, we have simplified this rational expression. Okay, good. So that's the easiest. We're going pretty much in level of difficulty. The next things we're going to tackle together are multiplying and dividing rational expressions. Okay, so here's a multiplication problem. What if I have x squared minus 9 over x squared plus 6x plus 9, and I'm multiplying by x squared minus 3x minus 18 over x minus 6. So again, we want to keep from being tempted to just whacking those x squareds, making them go away, right? We can only factor and cancel. All right, so we're going to factor everywhere we can. So difference of two squares for the x squared minus 9. This turns out to be x plus 3 times x plus 3. This turns out to be x minus 6, x plus 3. And then the x minus 6 can't cancel. So then I'm going to can't factor. So then I'm going to go ahead, and anything top to bottom that's the same gets canceled out. So the x minus 6's are gone, x plus 3 is gone, x plus 3 is gone, everything's gone except this. So our final answer is actually, no it's not, x minus 3. Okay? So multiplying rational expressions, factor, cancel. You with it? Dividing isn't that much different. There's one really, really important thing, and that is that we know that in order to divide, we must multiply by the reciprocal. Okay, so let's keep that in mind. So this time I have x squared minus x minus 12 over x minus 4, and I'm dividing by 2x plus 6 over x minus 5. All right, so dividing means to multiply by the reciprocal. Reciprocal of what? It's always the reciprocal of what you're dividing by. So I'm going to rewrite this, and as I rewrite it, I'm going to go ahead and factor as I go. So x squared minus x minus 12 is x minus 4x plus 3. X minus 4 can't do anything about that. Now I'm going to change this to a times, and I'm going to put that x minus 5 in the top and 2 parentheses x plus 3 in the bottom. Okay, and then I'm going to go ahead and come back and say I've got an x plus 3 here and x plus 3 here, x minus 4, x minus 4. Final answer, x minus 5 over 2. All right, how are we doing? We're doing great. Next one, addition and subtraction. when you were learning how to add and subtract, in the beginning you thought that that was easier than multiplying and dividing, but when it comes to rational expressions, it's harder to add and subtract because of that common denominator idea. So here's the first problem. When the denominator is the same, then adding rational expressions is super, super simple. We add the top, and we keep the bottom the same. And so, boom, we're done. Okay. But if the denominators are not the same, as in this one, so I have 6 over y plus 8, and I'm going to subtract 3y over y squared plus 11y plus 24. All right, so our goal here is we need a common denominator. So again, we look at the two of these. They don't look like they have anything in common at all, but if we factor the denominator on the right, we find we actually do have part of this in common. So we look at the two denominators and we say we need a new denominator that the denominator on the left and the denominator on the right will both go into. So that denominator is y plus 8 times y plus 3, right? If I multiply this by y plus, if I multiply this one by y plus 3, I get that denominator. And if I multiply this by 1, I get that denominator. So now that I have my common denominator, I'm going to go back and look at the numerator of each one and figure out what's missing in the denominator. So the 6 is only over a y plus 8, so we must multiply it by the other denominator, right? The 3y minus 3y is over both factors, so we don't have to multiply it by anything, all right? So now all we have to do is clean up the top, so we get 6y plus 18 minus 3y over these two factors, which becomes 3y plus 18 over y plus 8 times y plus 3. All right, we are done here. We might want to check by factoring the top, because every once in a while when you factor the top you have something that cancels, but in this case it does not cancel with the denominator, so we are good to go. We are done here. Remember that it is always okay to leave parentheses in the denominator. Try not to leave them in the numerator. All right, of course, if there are 5 or 6 sets of parentheses, you're not going to multiply them out. But in general, we don't like parentheses in the top. Okay, that leaves us to the last one, and that is to solve. And so we're going to go ahead and try to do this quickly. What's different about these is that there's an equal sign, right? And we know that when we have an equal sign, the directions are almost always to solve, all right? So here we go. We've got 3 rational expressions put into an equation, and our job is to get the x by itself. So I'm not sure how you learned how to do this, so I'm going to do it a long way that I think you probably are most comfortable with, and then I'm going to push you and try to get you to do it as shortcut. All right? So what we're going to do is, just like in the addition problem before, is we're going to find the common denominator. So I'm going to start out by factoring everything I can and look at the denominator here, here, and here, and decide what denominator is the common one. And I hope you can see that 4 times x minus 6 is the common denominator. All right? So now I just have to look at the individual fractions and see what I need to multiply to get that common denominator. So 3 over 4, the 3 must be multiplied by the x minus 6. The 2x is fine just as it is because it's already over that common denominator. And the 8, what's missing is just the 4, right? 8 is over x minus 6. Now it's 8 times 4 over 4 minus x. So once we get to this, we say, hey, the denominators are all the same, so wouldn't it make sense to just come in and cancel those denominators? And the answer is yes, it is. And so now all we're doing is solving the equation 3x minus 6 minus 2x equals 32. All right? And so when you finish this, you should get x equals 50. I'll let you do that on your own because I'm trying to get in under 10 minutes on this one, and I have one more example to do. So there is an easier way, and it's a little different. Instead of finding a common denominator and then canceling it, we skip that whole getting the common denominator. We just go right to canceling. Let me show you what I mean. Let's say I have x over x plus 2 minus 3 over x minus 2, and that's equal to x squared plus 8 over x squared minus 4. Okay, and our job is to solve this one. So we start out like we did before. We find the factored forms of all the denominators, and we say the common denominator is x plus 2, x minus 2. What we don't do is change these so that they have the same denominator. Instead, what we're going to do is we're going to multiply both sides through by that common denominator. So I'm going to multiply the left and the right sides through by x plus 2, x minus 2. All right, so I'm going to start here, and when I do that, so I'm thinking about it as a fraction over 1, can you see that the x plus 2 will cancel with this x plus 2? All right, so this x plus 2 will cancel with that x plus 2, and what we have left is x times x minus 2. Right? Now we're going to go back and do the same, and we're going to get rid of, let's see if I can, oh no, it took all of it. We're going to go back to that x plus 2, x minus 2, and multiply it by the second fraction, right? This time it's the x minus 2's that cancel. Can you see that? The x minus 2's cancel. So it's going to be 3 times x plus 2. On this side, when we multiply here, these cancel completely, and what we have is x squared plus 8. All right? We would have eventually gotten there. If you remember here, we had this in the last step, but they were all they were all parts of fractions, and since they had the same denominator, we went ahead and canceled them. So what we've done here is we've skipped a step. Okay? And so what we get is x squared minus 2x minus 3x minus 6 equals x squared plus 8. And when we clean it up, we get negative 5x equals 14, or x equals 14, negative 14 over 5. So I would say that this is the most preferred way. When you get to pre-calculus next year, they will expect that you can cancel those denominators instead of this method, which I think is probably the way that your middle school teachers taught you. So, hey, I'd like you to practice with this. We'll have lots of opportunities to practice with the shortcut in class. See you in class.